see why calculus is required in AI. Why it is important to understand the calculus aspect of artificial intelligence application model. Okay, so let us move ahead. So introduction to AI. So why we need to do? Why? Okay, so before I move to the next slide is very interesting. So it gives us a very compelling reason, like why we need to go for to learn AI. So can I quickly get some responses like why we need to learn AI? The first and major thing is the future gonna be in AI. Yes, it's a advanced technology. Any other responses? So we, in fact, directly or indirectly, we have been introduced to AI in our curriculum, and that other day or other, we have been going through that. But why now? Why now this AI is penetrated into industry? Why does it so much buzzwords right now? Yes, it may ease our life. It may reduce human effort. Yes, all these answers are very right. Yeah, cost reduce, increase in automation, a very important point, increase in automation. So what role AI plays in automation? Yes, because the world is going for AI. AI plus big data, very powerful. I have a very interesting meme so to show you that how AI and big data is linked. Okay, so let us move ahead. So why AI? Because I have a slide. In 2016, the AI market was worth $64 million by the end of 20, and the market value of AI is expected to reach and go exponentially, and it would reach around $38.6 billion in less than 10 years. So we'll see. So we are right now we are about to experience. We can just how many of us use Google Voice Assistant, or how many of us use Apple Siri? So there has been actually very interesting AI modeling is involved in Google Voice Assistant and Apple Siri, and for example Amazon Echo. So for example, the performance of those things, especially the performance of Amazon Echo. So when a person starts interacting with that Amazon Echo device, we feel as if we are talking with a person. So Amazon Echo is not just voice interpretation or that, it involves a lot of fields of AI. So it is, so I don't find any hype in making a statement that it will go exponentially and it will be $38.6 billion in that. And we all know the IT industry, we run on, so we do need a profit. We need to run our industry, and AI has penetrated like anything into IT industry. And our future work and our future living and the future of our families will heavily depend upon, or will heavily be governed by the AI tools or AI based gadgets and products which are being developed right now. So it's an actually very recent survey done. The source is tractica.com. So later at the end of this session I'll upload this PPTs to GitHub, then you can explore this PPTs at your leisure. So you agree with this statement that why AI we are going for that? Because it would be the form of business which we will be dealing primarily in the future. So let us move ahead. How is it different? So when I am into AI, so we have started like we are now we have just entered the building where the building name is AI. So we'll see what all this building contains, what all the floors of this buildings are, like how actually the building is built, and how this building is increasing its height in building floor by floor. So the first thing, it's very important to know before the term AI, we have been already into some domains like data science, data mining, machine learning, and there has been very interesting discussion on Stack Overflow. Over the discussions of this, we all know that the heaps on Stack Overflow have a very rational explanation to questions. So when we break in between for a curious readers and go through the Stack Overflow this discussion, like what exactly the difference is that. So let us see the difference between data science, data mining, and machine learning. So anyone already into data science? Anyone of us already into data science or data mining or machine learning? Okay. Mhm. Okay. So let us move ahead and see the difference between this one. Okay. So this is data science. So I'm clearing that out word by word because data science has been a buzzword before the word AI was a buzzword. So what is data science? So data science is nothing but it's a mixture of all the technologies like statistics, visualization, machine learning, pattern recognition, and neurocomputing all together fed into one single domain forms a data science. And data science primarily revolves around data. So it, it depends upon data. So uh, the main objective of data science is to how what all information I can extract from data and all the fields which are related to extracting the hidden knowledge present in the data. This all is related to data science. So you can see that we can see that here it has a so here we can see that it has a machine learning as a domain. So this is a very integral part of data science. So what is machine learning doing in a data science? So machine learning is actually a subset of AI. So uh, I want what I would like to say is that roughly you can consider machine learning as a synonymous to AI, but isn't actually completely true. So we cannot say that technically speaking, the one who has a good knowledge and background and all that is one. He won't say that AI is exactly equal to machine learning, but as long as we are using these applications in our IT industry, we can trust on that statement that machine learning is equal to AI. But technically, they are not same. So AI is very large. Machine learning is a subset of that artificial intelligence. So next, so okay, so how do I clear this? Okay, okay. So what is machine learning? So we'll see a few definitions from the major players, like uh, the definition which is very popular on internet. So what we see here is the machine learning is defined by Stanford as the science of getting computers to act without being explicitly programmed. The definition is very important. So we do program machines to work on few domains. We do program machines to automate few tasks. We do program a lot of algorithms in that. And it's very clear that once we write our code, it only behaves as I want it. It won't go beyond the instructions which I have specified. If I ask the instructions to do something, it will do it. Any specific outlier case for that or any exception that our programs fail, our conventional programs fail. So here comes the machine learning. So machine learning is nothing but it's actually an art and a science of writing algorithms in such a way that a computers by use of those algorithms can act without being explicitly programmed. So algorithms are self-learning. The algorithms learn themselves, they improve themselves, and day by day they become more and more intelligent. So that's the core of machine learning, what machine learning is. And what Wikipedia says about machine learning is even more quite interesting. What it says, it is a subfield of computer science that gives the computers the ability to learn without being explicitly programmed. To word explicitly, the common thing which we can see from Stanford and Wikipedia is that both say that when a computer gets the ability to learn on its own, even, even without a human intervention. So that's the core and essence of machine learning techniques. So what is ML and data mining? So before we see this, I'll quickly explain what we mean by data mining. So data mining isn't a new, it has been into practice. Uh, The data mining is nothing but it is a few set of algorithms, standard computer science algorithms, and the purpose of data mining algorithms is to extract some patterns and knowledge from data. So a special subfield of a computer science which only works on algorithms which can retrieve a data from a intelligent meta information from a data, and so such field of algorithms we call it as data mining. So the difference is quite evident here. So once we go through the definitions of ML and data mining, if we ask a question to ourselves, like, is machine learning is equal to data mining? The answer is straightway no. Machine learning and data mining are not equal. Machine learning focuses on prediction based on known properties learned from training of the data. And what data mining is, the data mining is analysis step of knowledge discovery, where the focus, where the main focus is on discovery of previously unknown properties of data. So it's like assume that if I want to correlate this, what machine learning and data mining is doing with what we humans do every day, is, for example, there's a field of stock trading. So most of us, we do stock trading intraday or day. So what we do before I buy some stock or sell some stocks, I do a lot of analysis. I check the company profits, I see patterns, I check a lot of news, and then when I keep on mining the information related to specific stock before I make a decision whether to buy it or not, So all that process becomes a data mining. And once you extract few parameters, like say, if this, upon doing some background investigation of a few stocks, I get from very few insights. So those insights are, based on those insights, we take a decision whether to buy that stock or to sell that stock. So taking decisions from the insights which I mine from my background data in a stock trading field is nothing but it's a machine learning. So once this distinction is very clear, then it becomes quite easy for us to understand. For example, say I have a problem and this problem needs a solution to be found out. So we need to analyze the problem in such a way that we need to come to a conclusion that solution to this problem lies in. So I'm seeing a mixed response. For few there's audio and few there is no audio. Okay, so I think we are back to this one. So I'll be relying on this mode of communication if something goes wrong. So I'll just type some messages on this one so that we can interact. Okay, so we're done with this. Okay, so so I was discussing on that. I'm not sure at what point I lost audio connection, but is the difference clear? What is machine learning and what is data mining? So I would like to even take few questions. If you have any questions, it's very important to clear the confusion here. So any specific questions on this? Like you want me to spend more time? Like what exactly is that? I hope I have cleared this difference between machine learning and data mining. Okay, okay. Okay, so I see some point like the predicting something based on data is same as analysis. Um, so you mean to say that? Okay, so okay, you mean to say that what could be the difference? Okay, let me say that. Okay, so you want to say that difference between data analysis, right? So when we talk about data analysis, it also involves data analytics as well. So the exact difference between data analytics and data mining is data mining always tries to find a new data patterns in the existing data. So essentially, a data mining would essentially involve data analysis. Unless we analyze our data, we won't be able to mine it. So the steps goes in this way. For example, the steps first it requires the data analysis. After analyzing the data, so what we analyze in data, that there are few data processing strategies like ETL, like MapReduce. We'll analyze the data. We will come to a conclusion of upon analysis of data that is this data relevant to me? Can I get something new from this data or not? So that is the outcome after data analysis. Once the outcome of data analysis is yes, I can get something from this data. Yes, this data contains lot of patterns in this. Then I mine that data for the patterns which I am interested in, or the knowledge which I am interested in. Based on knowledge which I get, if I write an algorithm which can use this knowledge to predict something, like the way we humans predict. For example, we analyze lot of investment opportunities. We do lot of analysis before investing into mutual funds and all that, and then we come to a decision that yes, this mutual fund will be the best for me. So all this, we are taking a decision. Assume that an algorithm is doing all analysis of mutual funds, and it is giving you, in the end, it is telling you, see, this mutual fund is best for your family based on whatever input which you give. Like, this is my family, I have this much amount of salaries and whatever, all that. So that process becomes a machine learning. Okay. So I hope I've cleared. The step goes in this way. The first analysis of data, and then it goes into ML. So clear? Yes. Okay. So let us move ahead. So this is a clear definition of machine. So machine learning are algorithms. Data mining is basically trying to get a knowledge from data. And we want machine learning is nothing but an algorithms which can learn from that knowledge. Okay. So here is one more difference. So what would machine learning and data mining? It's a few table summary of a table for you. So what it says, the techniques available in data mining, these are the very famous techniques available in data mining. So for example, we'll try to find out association rules, very famous among e-com companies. We have a classification, clustering, sequential pattern analysis, and sequence similarity. So what is involved in machine learning? It involves supervised learning, unsupervised learning, and reinforcement learning. We'll see this. What are the three types of machine learning in a subsequent session, and how the relationship is in data mining and how it is in. So you can see the few examples here. For example, forecasting a weather based on analyzing all historical data of weather, classifying things, associating similar things, clustering into groups, sequence making, and what is machine learning? What can machine learning do is automating employee access control, protecting animals, predicting emergency, identifying herd failures. So these all are. So as and when we move in this session, we'll be keeping on coming with examples and examples. Okay, so this is ML and data mining. And now here to a diagram where we'll see what is AI and where does it fit in our broad domain of computer science. So we can see here. So this is where AI is. So you can see the AI circle. It is majorly, it is including machine learning. The entire machine learning is a part of artificial intelligence. So basically, when I say that I am building an AI machine, when I'm building that, or if I say I'm modeling an AI application, that would involve machine learning, that would involve the collection and curation and a maintenance of all the knowledge related to that domain. And it also involves in finding how humans, if had been a human asked to solve that problem, how would a human solve that problem? We do also need that data in order to build a very intelligent AI application for a specific problem domain. So for that, we call it as reverse engineering the brain. So this step is essentially nothing but to understand how a human would have solved that problem. Because nowadays, right now the AI is popular because the current state of the art AI algorithms, they're highly based on what human mind does. And here is where data mining is sitting. We won't need an entire data mining in AI. So there are a lot of data mining things, but we need a part of data mining so that our machine learning algorithms become more and more intelligent. Okay. So let us see what is AI in terms of. Okay, so I'll finish this session and then we'll take few questions in this one. Okay. So any questions on this diagram? Okay, so let us take a questions on this because this slide has few domains: machine learning, data mining, and AI. So how does this what do you think that is this chart? Is it depicting the entire thing? So you can see that the input to all this is actually a big data. So whatever the data which we have, all that is the input to this domain. So let me go to a question. So Bhagyashree has a question here. What are the different tools required for data mining or machine learning? Okay, so I'll just wait for some questions here. How do we do it? Okay. So okay, so I'll take questions one by one. The first question which I have here is, what are the different tools required for data mining or machine learning? Yes. So there are a lot of tools. For data mining, the open source which is available to us is there is a tool called as Weka. So let me just type it here. So for data mining, there's a tool called as Weka. So we can explore, like once we have our data in a CSV or in RDBS format, we can use this tool called as Weka. It's a data mining tool. And it's completely free and open source. It's open source. And as far as tools for machine learning is considered, there are many. Right now, the very most popular tool for machine learning, especially a machine learning tool focused for a particular branch of machine learning called ANN, it's a TensorFlow. Very popular, very successful, and So I was just falling short of words to describe TensorFlow because I've been monitoring this AI field since years, and I can just imagine like how popular this TensorFlow is. It's a tool for ML. Okay, and we do have a lot of other tools which are all based on Python. Python is it's a darling of all machine learning mathematicians and that. A lot of tools available in Python. A single Google query will give you a lot of tools. So let me take and one more the questions available here. Okay, there is what is the difference? The second question goes to is question final decision based on data analysis. You still need a code, right? Okay. So what you're asking is the question is to make the final decision. Okay. So upon doing an analysis, how do we take a decision whether the data which I'm analyzing is it suitable for my problem domain or not? So we do have some few set of feature sets. So we look for few patterns. So what are those patterns? What should I look when I'm analyzing this data? So all those things, they're highly specific to that domain. For example, assume I want to build a stock trading application, auto stock trading application, and if I'm analyzing all my stock market data, so I would look so when I'm analyzing that data, the main thing I will look, does this data actually contain the fluctuation in a stock prices every day? So that's what I will be looking for. So in order to look for that, yes, we do need a small code. And nowadays, this ML domain in algorithms are so large and they're so stretched. We do have a very intelligent algorithms right from data analysis to the prediction. So hope I have answered your question. So what is reverse engineering the brain? So a question by Ishwar. What he asked is, what is reverse engineering the brain? So here we can see the reverse engineering the brain. So as I've been telling, so assume we'll keep on coming to this example of the stock trading. Assume that I want to write an application which can auto trade, so it can trade like a human. So if I want to build this auto stock trading application, what I need is first I need to know how a human would trade a stock. So I need to reverse engineer the way human would trade a stock, like what all a human does. How does he come to a shortlisting stocks and that. So that aspect of analyzing the human way of solving that problem is called as reverse engineering the brain. So it's very important when we model our AI application. We need to know how humans are solving, because AI now is popular because it is adapting itself to solve the problems our human brains solve that. Okay. So I hope I have cleared your answer. What is reverse engineering the brain? Okay, so one more question. How do we do it? So it's based on capturing the semantic information. How do we reverse engineering a brain? We have a slide coming in a further series. We'll see how do we capture like what humans are doing, what humans think and all that. What is curated knowledge? The curated knowledge is nothing but it's the domain knowledge, the pure domain knowledge related to specific domain. For example, if I want to write a medical diagnosis as artificial application, so all your medical related knowledge, the semantics, the ontologies, the meta information, all that is called as curated knowledge. Does ETL, Hadoop fall in big data? Yes, they fall in. They are not a part of big data, but they are the frameworks which analyze, which let me process big data. There's a question by Rajeshwari. What she asked is, do we have a specified algorithms for reverse engineering? We do not have a specific algorithms in the sense, but there's a standard set of processes. Like assume I want to get a domain knowledge of a domain. There's a standard set of processes. It's been, but there isn't a thumb rule that you need to stick to this process and that. The only thing is that we need to know what is the algorithm which I'm writing, the intelligent algorithm I'm writing. It should know that this is how the humans solve. How can that algorithm can benefit from what the way the humans are already solving that. So the last question which I see here is, does R play a role in machine learning? Yes, it plays a very important role, but it lets me use some of the mathematical foundations which we're going to discuss in a coming sessions easily. So I did not write a method. So assume that if I'm using the R, I did not write code to calculate standard deviation, all that. So it reduces a lot of work of machine learning. The developer who is writing that machine learning or AI application. Is Python only way to AI, or is there any other language to create AI? Yes, there are other languages to AI. Java is also popular, but Python is bit, as I told, that the most of research which is happening in AI, that research is being done by mathematicians, and for them Python is, they like Python much. So unfortunately the developers too have written a lot of Python libraries. So there we won't, I won't say that Python is the only way. We do have other languages, especially Java is also very famous with AI. So what are all the skill sets required to move into AI? Okay, the main skill set, very important question. What all are the skill sets required to move into AI? The first and foremost is to the ability to understand a problem into a mathematical concept. So that's very important. So unless I model my problem first into a mathematical model. So what is mathematical model? So many people say they model your problem into a mathematical model and that one. So we'll clear that what exactly the mathematical model is. As of now, I'll tell you that representing our problem into a mathematical function so that my algorithms and my math-based frameworks, they can easily work on that. Your computers understand binary. So this binary language is somehow very modified so that it can also understand your machine learning system. Okay. Is machine learning differ from AI? Machine learning, you see, I would call machine learning as a subset of AI. It isn't machine learning. So machine learning, the core of machine learning is to write an algorithm which can learn. And if an algorithm wants to learn, we humans always learn from experiences and expertise. So we learn from experiences. So for an algorithm, experience is nothing but the data. So few set of all the technologies and the methodologies which let me collect intelligent data, which will let me store data in intelligent, which let me specify how the relations in that domain is involved, and which let me know like how should I interpret the data. Collection of all this together is called as artificial intelligence. So last question, anything in Microsoft languages? So .NET is bit very specifically, I have been through C# modules. Yes, we do have few C# modules which can directly which can interact with the Python module. So we can use a Microsoft technology. There isn't any restriction that Microsoft technology is not that. In fact, Microsoft Azure, the cloud offering of Microsoft Azure, has a special machine learning studio. So which lets you write your machine learning algorithms in .NET. And those algorithms can take advantage of Microsoft cloud infrastructure. Okay, so hope I have cleared this question. So are we all set to move ahead? RPA is a subset of AI. Yes, RPA will essentially use machine learning. Yes, so if you are into RPA, it would be very easy for you to move into AI and machine learning. So most of concepts you might have already studied in robotic process automation. So RP is nothing but the intelligent automation. Right. Okay. So shall we move ahead? Few more questions. So I hope I have cleared your answers. Okay, shall we move ahead? Okay. So yes, so let us move ahead. So we have seen all these domains, and let's see what. So we will do a very interesting experiment. If I open a Google and if I type what is AI, since Google search is now lot like AI, it uses a lot of AI within that. So what we are saying that, assume if I do a Google query on for an AI, this is what Google tells me. And I like this definition very much. So essentially this captures, it puts the word artificial intelligence in such a way that it becomes very easy to understand what is AI. So what Google says is, AI is the theory and development of computer systems, and these developed computer systems will be able to perform tasks normally requiring human intelligence. When I talk about human intelligence, what all factors capture the human intelligence? So specifically, we humans are intelligent in visually perceiving some scene or visually perceiving. We have a very best of speech recognition. We have a decision-making abilities based on the vision perceptions and the speech recognitions which we have through our sensory organs, and we are the perfect translators available on this world. So we can easily translate between languages. So we have been doing it incredibly very fast and incredibly in a way that till now machines aren't able to do it. But Google has pioneered the effort of translating. Okay. So how many of you like this definition? Does it clear your doubt, like what exactly artificial intelligence is? Artificial intelligence isn't a machine learning. When I say machine learning, I'm actually into coding, algorithms, and all that. But when I say artificial intelligence, it involves all this. Okay. So do you like this definition of AI? So I personally like this definition a lot. Okay. So let us move ahead. Shall we move ahead? Okay, so there's a question, is there any tools to run this AI? Yes, there are tools. We're going to see those tools in the coming sessions. So we won't be putting all in a one day because it becomes too heavy to grasp the concepts of AI. Okay, so we'll move to the next slide. Okay, so this is what I was talking about. So it's the one which is our future. So we all know like how industrial revolution happened. So there's a word in industry which we say that AI is the next industrial revolution which is happening. So for an AI, for a future of us is in this form. The data is the new oil and AI is the new electricity. We all know that all oil companies are the most richest companies which we have in the world, and we do know that how important electricity is now. So in the future, the data is the new oil and AI is the new electricity. Okay, so let us move ahead. Okay, so here we have a few set of slides where we'll see like what was artificial intelligence earlier, how did it evolve, what's the problem, what problems AI faced earlier, why our IT industries didn't adopt AI earlier, why now, what are the problems, can we overcome those problems now? Yes, we have overcome those problems now. That's why the AI is popular right now. It's been now it's the mainstream part of our IT. So let us move these slides one by one. So once we finish this introduction of this, we'll take a short break and then we'll continue with the mathematical foundation. Okay, so a brief history of AI. So initially, the term artificial intelligence was first coined in a academic conference during year 1956 at Dartmouth conference. The term artificial intelligence was coined in a proposal for a conference in that. So though the term was coined in 1956, nothing has happened much in the latter few decades. So how did it evolve after that? So one of the early research in AI, so the then industries and then researchers, they were frequently facing the problem of search and optimization. These are the two mathematical problems, the search and optimization technique, especially as a subdomain of mathematics, wherein there are a lot of techniques like how do I search, how do I optimize something in that. So most of the research in earlier AI was just concentrated on effective searching and effective optimization. So first, AI was based on tree-based decision making. We call it as decision tree classifiers. So it was then, but the problem with those set of search techniques was space and computing power was not available freely to most of organizations. That was very costly resources at that time. So what has changed in recent years, in the last few decades, what has changed in recent years? The real success of AI was achieved when IBM's Deep Blue actually defeated the top chess grandmaster Gary Kasparov in a chess match. So it was a very motivating effort. It was very motivating for then researchers. That it was also very interesting. It was surprising to find out that a machine was able to defeat a human, and that to a chess grandmaster. And we all know how popular the Gary Kasparov was during that day in playing with chess. But for some reasons that didn't go well off to current AI. The major issue with then AI techniques was the same: the lack of computing, the lack of parallel processing algorithms, and the lack of cheap hardware resources, so high performance computing resources. So, and even research in AI was not at all affordable to large organizations. So we can just imagine like what a small organization could have done and in those old days. Okay, so once we had that, we in a theoretical wise as well, there was an in-between branch called as deductive logic. This has been famously known in technical words as a theorem proving engine. So we in IT people, we rarely use the theorem proving, but it's mostly used with researchers doing research in that. It is nothing but it's like rule-based systems in which we specify free rules and we see that whether a specific we make a statement. We already have a rule, and we just take the validity of the statement which I made. For example, if I consider the statement, so if I make a statement like all men are mortal and Socrates is a man, then my system should be able to deduce that Socrates is also mortal. So the same thing when represented using some the first order logic, it translates in this form. So this is called a theorem proving. But the major problem with this was that the deductive logic system, they had no way to capture uncertainty. And we all know, like in a real world, the real world is always governed by uncertainties. So, okay. So this was, we call this a deductive logic. So let me move to the next slide. Okay. So there was a question earlier, like how do I capture the curated knowledge? So when I say I'm using a curated knowledge, I want to capture the knowledge of a specific domain. Uh, Nowadays, the best of state of art, the technologies which are available to capture the background knowledge, the knowledge we humans we keep on our mind. We call them as semantic networks, and now we have something called as ontologies. You can Google it whenever we have. We have a concept called as ontology. Uh, it's we do also have OWL language, ontology web language. So what this do is, this let me capture a background knowledge. For example, you can see this, a small graph depicted here. I took it from a Wikipedia. So what it says is that we are capturing a small knowledge, like cat is a mammal, it lives in a, like we have a whale is also a mammal, it lives in a water, fish lives in a, it's an animal. So this is how we do it. So it's a different domain, like how do I capture this knowledge, or how do I input, or how do I store knowledge in that. But nowadays it's an essential part of an broad AI domain. So more the rich background knowledge and the domain knowledge we have, more realistic AI applications we can build. Okay, so we have seen some few slides on a brief history of AI. So this suffered from one few major problems. So these were the three very limiting factors for earlier researchers, due to which AI couldn't develop much. The major problem what earlier the few decades back the AI researchers had, and why this area was into back burner for so many long days, and why now it has picked up. The major problem is limited computing power. There was not enough memory or processing speed to accomplish anything truly useful. And most of the problems in AI and most of the algorithms which we use in AI, they are intractable. So intractable are something which this relates to algorithms. So those who had a degrees in, those who have a graduate degrees in computer science, they'll understand, like when I'm talking about tractable, intractable. So these are the complexities of algorithms, the polynomial and non-polynomial complexity. And we know that an algorithm which is polynomial complexity is the best what my machines like, what my CPUs like. But if an algorithm has a non-polynomial complexity, we call them as intractability. So these algorithms, they become worse and worse as the size of input increases. So normal computers can't even run those algorithms on our normal machine. So it requires heavy resources. So most of the algorithms in the machine learning and AI date back, they're all intractable and they suffer from a problem called combinatorial explosion. So does anyone know what is combinatorial explosion? So it's a very interesting to understand, like why this combinatorial explosion is still an issue for a lot of us. Even now, when we write our AI applications, we need to very carefully see that we do not encounter this combinatorial explosion. So any idea? Does anyone have any? Anyone has an idea of what combinatorial explosion is? I'll explain, but I would like to first see, like, if you all know, if someone else can. Okay, okay. So what the combinatorial explosion is nothing. I'll just assume that. Okay, so we all use ATMs. We all use ATMs and all that. So ATM has a PIN number. So we can assume. So assume that I have a small. Say I developed a small web application, username and password, and I'm asking user to enter only 2 length password. So at max, you can enter A, B, B, C, D, E, or only two words. So if I have such a password system, anyone can easily guess that, because the number of combinations of a 2-lettered combinations in a say in a 26 alphabet is at max you will get some thousands or some thousand, and this can be easily run by a brute force algorithm. So those combinations I can try and assume if I involve one more, if I increase the password length to 4 characters, and I allow user to also include a few numbers and alphabets as well. Now the number of combinations which I'm supposed to try in order to crack that password by using brute force in the sense trying all the combinations. Just the number of combinations, they exponentially grow. Earlier it was just a few thousand, but suddenly they become in the millions. And then if I further increase the length of characters of a password, say to 8 or 16 characters, and if I put a additional requirement of special characters and that, we can just imagine on such a system, if I'm supposed to run a brute force algorithm, it would have to check millions and billions of passwords. So this is one. So when you try to solve a problem by trial and error, we can solve it max when I have the less number of options to be tried. But if I have billions and millions of options, I cannot do that. So algorithms which are trial and error based, they are only suitable for a few extent. But the more and more options keep on growing, the algorithms can't even run at for all those options because there's an explosion of combinations to be tried. So the same is still it's a very problem in all AI whenever we try an AI, but we do overcome this combinatorial explosions with the help of heuristics and machine learning algorithms like training, supervised, and there are things. We'll keep on saying that in coming session. So these have been very major problems of earlier AI systems. They suffered from intractability and combinatorial explosions. So now we have some very good ways to overcome this problem. And the third major factor which limited AI development was common sense knowledge. So most of the AI, they were not taking any natural language into consideration, and neither was any inclusion of probability in that. So we know that only real world is very uncertain, and we do expect our machines to also behave like a humans when the algorithm goes in a situation wherein the outcome is uncertain and it is supposed to take a decision. So that's what makes the applications intelligent. So then let us move to the next slide. So what is AI today? So what is AI today right now in current context, in current year and that? AI today now greatly benefits from incredible power of computers today we have. Nowadays hardware is very cheap. We can just imagine, so for 5-4 years back, we had a small single core mobile processors. Now we have octa-core and hexa-core mobile processors and that. Computing is now not a limitation. We can get very high powerful computing machines on a cloud as well. Earlier, if I'm supposed to write a algorithm on a very HPC cluster, high performance cluster, I had to go to large data center with such funding and all that. Now the cloud computing providers like Amazon, Microsoft, they give me virtually they give me a supercomputing power for a few amounts. So neither I'm not required to bother about cost and all that. And the second is the creation of a new ties between AI and other fields working on similar problems. So now we have an internet. There is a lot of knowledge sharing, and the AI development has benefited a lot from the knowledge from other fields, right? From development. For example, a few years back, we didn't even know how our brains used to function, and now still now we don't even know the 100% how our brains function, but we know right now that our brains are based on a concept called neurons, and the way neurons function, the way we also modeled artificial neural networks and all that. So now the medical sciences research, we know more and more details. We have a lot of knowledge coming from other fields that has actually really benefited the development of AI right now. And nowadays we have a very new and a solid team of researchers working on mathematical models, improving the computing, improving the algorithms, improving the study and all that. So it's really benefiting AI. What is more important is understanding of probability and statistical theory. So very important. Those things are very important in AI. And we see there has been significant progress has been achieved in neural networks. Probabilistic methods. Neural networks are the way to mimic working of our human brains. Probabilistic methods are methods which capture uncertainty. For example, if I'm supposed to predict whether it will rain tomorrow or not, there are a lot of factors to answer that question. And even if when I answer, I cannot answer like with 100% guarantee. So such domains require a probabilistic treatment. And we have a statistical machine learning. The statistical machine learning is nothing but the machine learning which learns from data mining and statistics of analysis of the data. And we have machine perception, excellent computer vision and speech. So one of the very interesting thing to note is the computer vision and speech recognitions have improved greatly. Greatly in the sense they've improved very greatly. So the performance has doubled in very recent years. So the performance what my computer vision and speech recognition thing, which they had in 2012, that performance is double right now. That's only because of a concept called as deep learning. So this is how the AI right now is benefiting. So in a summary, what we have seen, AI has been into existence since 1956, but it was not into the mainstream IT until late 2012. Then why AI is back now? Because of the few reasons: rapid availability of cheap and incredible high computers, rapid research of niche mathematical fields, and deep learning. Yes, deep learning is which forced companies like Google, Amazon to adopt AI. Earlier, these companies were shunning away from using AI because they weren't sure, like, will AI give them any benefits or not. But they have used it and they have pioneered the use of AI, and now we can see that how intelligent they are working. We have AI is benefited, and right now AI is more a probabilistic and statistical approach of problem solving, and success achieved in recent times. So especially the success achieved by Google in using AI and its voice assistant, search, the YouTube recommendation. There's a special project by Google called Google Brain. You can Google when we break for break and all that. So Google Brain is a special initiative of Google where it develops in that. So success achieved by those tech giants has motivated the smaller organizations to adopt that. And once they've adopted, now you can see the where AI is and how deeply it has penetrated right now into IT industry. So what are AI applications? So these are the few AI applications right now. Most of the AI applications now they go into natural language processing. Now, rather than calling natural language processing, now the term which is used is to say natural language understanding. It's very key because most of our human way of interacting and exchanging information is by either by writing something or by speaking something. So if a machine learns from a human, as right now, so now I'm delivering a lecture, now I have to PPT and that. So one human is delivering the knowledge and other human is learning that. So if if machines develop this capability, then virtually there is no limit for application to develop itself. So very important, very crucial developments these are: natural language understanding and speech understanding. And the machine translation, information retrieval and text mining. These have been into industries earlier, but now they have benefited from AI. Pattern recognition. Yes, computer vision and speech recognition. These two sectors have developed, they have benefited from deep learning like anything. So now every image processing now they want to use deep learning because very great approach. So what is deep learning we will be saying in a day 3 or day 4, but for the time being just see that deep learning it has benefited like anything to computer vision and speech recognition. And we do have applications in social and business intelligence like social customer behavior modeling. We all know like the Visa, credit card fraud detections and all that. Now they're all AI based. So still this area of deduction reasoning is into there, but it is mostly into automatic game playing engines and that. So few days back we heard that Google's Google had a project called Google DeepMind. It was calling it as Alphago, which defeated the Go champion, the Chinese Go champion. And I'm not sure like if you have played Go or that, but it's a bit very tricky. It's like playing chess. But the only thing is, we can write an algorithm to play a chess because it just involves checking the combinations and that. But to write an algorithm to play a games like Go itself is a game. So I'll just type what I'm talking about. Go is a game. So Google had a system to play. We call the Google DeepMind. It was calling it as Alphago. Okay. So that's based on deduction and reasoning. Knowledge representation, we have expert system, automated planning and scheduling. So this is where the RPA comes into picture. Automated planning and scheduling. Motion manipulation. Robotics are also benefiting very much from AI. So this is actually a last slide. So I took this slide so to show you that the recent boom of companies which have used AI and they're working on AI, these are very popular companies. So they are working into AI, and I hope some of you might have already dealing with that. Okay, so once this slide is done, we'll take few questions, and then we'll take a small break. Then we'll come back and we'll see mathematical foundations, and we'll see some of the basic introductions of calculus. A small disclaimer: the next sessions will be a little bit mathematical, so better we have some strong cup of coffee now. Yeah. So we'll break shortly, but we will first see. So, any experience with any of the companies working with this? Has anyone had any experience working with any one of these companies? Okay. Audible, right? Okay. Okay. So these are companies. They are right now they are making a lot of profits. There are a lot of famous into that. For example, there's been a Indian consulting. So I would like to tell you that there's been a company. There's a company. So let me clear this first. Okay. So there was a company called as Harley Labs. It was an Indian AI consulting lab. Surprising thing is it's been acquired by Google. So you can see how famous and how demanding the skills of AI right now. So very interesting to note that. So no one even knew like what was Harley Labs, but the day when Google acquired that, it just made into headlines like So that. So there's a very heavy. This is a field which is going to rule the industry, IT industries, and our IT for coming years. And I definitely believe that AI will be the future here. So these are based on the area of that. For example, these are all our bots like Clara, the Minefield, this Vision or Clarify. Okay. So an interesting thing I would like to tell you, there's a small chatbot built on deep learning. We call it as Cleverbot. You can Google for Cleverbot and you can try conversation with that. You will feel like how advanced the AI systems have been developed right now. So they as if like a human, they start with you to talk, chat to you as if a human is talking. Still we do find some outliers in that, but the things are evolving. So these are AI startups. Okay. So any questions? We'll take a few questions here. So questions please. Okay. Good understanding algorithms required to develop AI. Yes, absolutely yes. 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 So understanding of algorithms is a prerequisite. Yes, you need a very good understanding of AI. So so I would like to also tell you that assume that if I feel I'm not a coding guy,